equations in one variable with the variables on both sides. You should all be on page 231. Should be on page 231. All right, so we're going to start off by reading the problem. We can read it together. 3, 2, 1. Emma is 1/4 as old as her father. In 20 years, Emma will be half as old as her father. The equation 1/4 x plus 20 equals 1/2 times the quantity x plus 20 represents this situation where x is Emma's father's age now. How old is Emma's father now? How old is Emma now? Okay, so we want to know how to find their ages. So to find their ages, we have to look at this equation, which they've already given us the equation, but you got to look at the questions that's asking. It's saying, how old is Emma's father now? And how old is Emma now? So those are two questions that we're going to have to answer when solving this problem. Okay? So first thing you want to do is you want to define your variable. Okay? So I want you to first define your variable. We have the main variable we're trying to find is Emma's father. Okay, because if we know how old Emma's father is, then we know how old Emma is. Okay, so we're going to set up this equation as written, but we got to define our variable. So we're going to say let x equal Emma's father age. Okay, so looking at the problem that they already gave us, which is 1/4 x plus 20 equal to 1/2 times the quantity x plus 20. First thing I'm going to do is get rid of that fraction. I know fractions are y'all friends, but baby, we're going to get rid of this fraction, okay? So we have to find the least common denominator. The least common denominator, again, is 4. Because if we set up 2 and 4, and we do the factors, we have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Then we have 2 times 1 is 2, 2 times 2 is 4, and 3 times 2 is 6. So we look at the factors to find the least common denominator, and the smallest number they both have in common is 4. So 4 is the least common denominator. So I want to multiply both sides of the equation by 4 in order to get rid of those fractions, okay? So I have to multiply this side by 4, the entire quantity, and the other side of the equation by 4. Okay? Now, remember, to multiply fractions, I have 4 times 1/4. I'm going to place this 4 over 1. That's going to give you 4 over 4, which equals 1. Okay? And we've multiplied 4 times 1/2. You're going to place that 4 over 1 and multiply across. 4 times 1 is 4, and 1 times 2 is 2. And 2 divided into 4, it goes 2 times. Okay? So I did that scratch work on the side because we have to apply the distributive property. We're going to distribute 4 times 1/4 x and 4 times 20. So 4 times 1/4 x plus 4 times 20 equal to 4 times 1/2. And remember, because that fraction's on the outside of this parenthesis, I do not have to distribute that to the 20 because that 4 is only being multiplied by this 1/2 only. So everything else will stay inside parentheses. Let me make that another color so you see what I'm talking about. So that's going to be x plus 20. Okay. So now we multiply 4 times 1/4 x. We already did our scratch work on the side. So 4 times 1/4 gave us 1. So that gives us 1x plus 4 times 20 is 80 equals 4 times 1/2. So 1/2 of 4 is 2. And inside parentheses, we have left x plus 20. Okay. Now I want to apply the distributive property on the right side of the equation by distributing 2 to both terms. So I have now 1x plus 80 equal 2 times x plus 2 times 20. So it gives me 1x plus 80 equals 2x plus 40. Now again, I want my variables on one side and I want my constants on the other. My variable on one side and my constants on the other. Okay, so I'm going to subtract my 1x from both sides because my coefficient is larger on the right. Okay, so this will cancel. So now I have all my variables on one side. Okay, so now I want to bring my constants on the other side. Okay, so now I'm going to subtract 40 from both sides. Now this cancels. So now I have 80 minus 40 is 40. And 2x minus 1x is 1x. I know 1x means, what does 1x mean? It means 1 times x, which equals x. So 40 equals x. So what did x represent in the beginning? X was Emma's father's age. Okay. So it says in the problem that Emma is, how old is Emma now? Emma is a fourth of her dad's age, right? So we're going to go ahead and we're going to figure that out by going to the next page. We're not going to answer all the questions now, all right? So we've done the work here, which means we can actually skip page 2, not page 2, page 232. So if we go to the next page, okay, they're basically showing all the steps that I just showed, okay? The model it part at the bottom is saying, hey, I want you to distribute that 1/2, which you could have distributed that 1/2 first instead of getting rid of the fractions. But fractions are so confusing for most students, we try to get rid of them first, which is what we did here, okay? Okay, so we did that on both. So if you would have distributed that 1/2 first in the problem, then you would have gotten the bottom half, which is 1/2 times x is 1/2 x, and half of 20 is 10. Okay, so this is how they demonstrated this second problem. I'll walk you through the steps in case you just want to know. So once you distribute that 1/2, you get the next line, 1/4 x plus 20 equals 1/2 x plus 1/2 of 20. Okay, then all I did was simplify the 1/2s. So in the next line here, they show what's half of 20. Half of 20 was 10. And everything else stayed the same. Okay, so the next line they combine like terms. They combine like terms. So when like terms were combined, they subtracted 1/4 x from both sides. See? They subtracted that 1/2 x from both sides, which got rid of this 1/4 x on the left. Okay? So they subtracted 1/4 x from both sides. Okay, subtracted 1/4 x from both sides. Okay, and I'll go ahead and add to the beginning here on this line so you know what they did. They distributed 1/2. Okay, so they used a distributed property there. Okay, on this line, all they did was simplify. All right, and of course, on the next line that we're on, we combine like terms by subtracting 1/4 x on both sides. And here, all they did was simplify. All they did was simplify. Simplify. Thank you. All right. So we want to do half. So here, and I'll show this little scratch work of here. 1/2 and 1/4, you have like terms, right? So the common denominator is 4. So 1/4 stays the same, but 1/2 is equivalent to 2/4. Okay. So in this problem where they have the 1/2 x minus the 1/4 x, that's basically 2/4 x minus 1/4 x, which equals 1/4 x, which is how they went from this step to this step. Okay, so half of a fourth is 1/4. Okay, so on the next line, they combine like terms. They combine like terms by subtracting 10 on each side, of the equation. And then that simplified this side, right? Leaving you with the 1/4 x, and 20 minus 10 is 10. Okay. So I've explained the steps up top here on the previous page, so I didn't go over that again. But I wanted to explain the bottom because that's if you wanted to work it out with just explaining the fractions. Okay. All right. So I can write the steps up here if you want to make it really quick. Here, we multiplied both sides by the least common denominator, which you call the LCD. Yeah, barely got it in there. All right. In here, we just simplified on this line. Here we distributed property. We distributed the 2. So the distributed property, we distributed this 2 to both terms. Okay. Here we combine like terms. And we combine like terms here by subtracting x on both sides. And then all we did here was simplify from the previous line above. All right. So now you have all that in your notes. We can now go to the next page, which is page 233. So page 233, we're just breaking down the problem that we did just now to actually simplify it a little bit further for your understanding. Okay. So it says use the problem from the previous page to help you understand how to solve linear equations in one variable with the variable on both sides of the equation. So the first we want to explain what each part of the equation means. Okay, so if you understand what each part means, it'll be easier to solve. Okay, so we look at this first part of the equation. We have 1/4 x 1/4 x is what? That's the age of Emma. Because she's, remember, 1/4 her dad's age. Okay? We know that x, what does x represent? X represents exactly the Emma's father's age. Very good. Okay. And 20 years later, the x plus 20 is Emma's father's age in 20 years. And the 1/4 x plus 20 is Emma's age in 20 years. Alrighty. So now we're going to look at number 2. Number 2 says, look at both models, both model its, and why does it make sense to multiply both sides by 4 first in the first model, it, and why does it make sense to use a distributed property first in the second model, it? Okay. You should pause the video and answer questions 2 through 5, and then we'll come back and check your work. So right now, go ahead and pause the video. All right, now that you're back and unpause the video, let's go ahead and check your answers. Now, you don't have to have the exact answers, but you should have something very similar, okay? So for number 2, it says look at both model its, and we want to make sense of the equation. Why do we multiply both sides by 4 first, okay? So you should have said something about eliminating or getting rid of the fractions, okay? So we can say because the least common denominator is 4, when we multiply both sides of the equation by 4, we eliminate means to get rid of the fractions. That's the first part. Then it said, why does it make sense to use the distributed property first and the second model? Okay. So when we distribute 1/2, it eliminates means to get rid of. It eliminates the parentheses. All right. So again, we distribute this 1/2, then we no longer have any parentheses. Okay. All right. Number 3. Number 3 says we'll look at both models. Finish a solution for each method, and which method doesn't matter which solution that you use. Look at both model its, finish the solution for each method. Doesn't matter which solution method you used. Okay. So you should have looked back at the problem right before it, and you had 2 problems. You had 80 equals x plus 40, and they say solve that method. And then you also had 10 equals 1/4 x, and you had to solve that as well. Okay. So For this first one, you should have subtracted 40 from both sides. That cancels, and you're left with 40 equals x. For the second one, in order to get rid of this fraction, you have to multiply both sides by the reciprocal. So the reciprocal means to flip the fraction. So the denominator becomes a numerator, and the numerator becomes a denominator. So you're going to multiply 4 over 1 times 10, and you also will multiply 4 over 1 times 1/4 x. Okay, this gives us 40 over 1 equals 1x. Therefore, 40 equals x. So you get the exact same answer for both. You get the same answer for both. Okay? So it doesn't matter which method you choose, you just pick the one that's best for you. In my opinion, I'd rather not deal with fractions, even though I can do them very well. I just choose not to do it as my primary means of working a problem. Okay? So if you're wondering where I got those from, remember in the previous page in the model, it's the problems that were left unfinished. This was left unfinished, and this was left unfinished. Okay? So that's why they told you to solve both of those, which us ended up to number 3. All right? So number 4, it says, what is Emma's age now? What is her father's age? Okay? So X was Emma's father's age. So Emma's father, let me change the color. Emma's father is 40. Okay? And Emma is 1/4 her father's age. Okay? So 1/4 of her father's age gives us 40 over 4. Therefore, Emma is 10. Okay? So Emma's father is 40, and Emma is 10 years old. Okay? So Emma's father is 40. I'm going to put years old behind that. Don't leave him hanging. And Emma is 10 years old. All right, for the reflection, your answers may vary, but I want you to think about all the models and strategies that we discussed. Describe how one of them helps you better understand solving linear equations with the variable on both sides. So this one, I'm going to ask Ms. J or Ms. Banks to go ahead and check your answers, because here your responses will vary. And I'm asking that they check the student responses. All right. So I want you now to go to the next page. And it says apply it. I actually want you to do number 6, 7, and 8 right now on your own. If you have more class time left, go ahead and do 6, 7, and 8 in class, and then pause the video and come back and we'll check your work. All right, now that you've worked the problem out and you've unpaused the video, we're going to go ahead and work through it so that you can see what your answers are. All right, so for the solution, first thing I want to do, I want to get rid of this fraction. So to get rid of this fraction, we have the denominator. I'm going to do it both ways in case you distributed the fraction or if you didn't. Okay, so our least common denominator, let's see here. Our least common denominator, we got to look at 2 and 3 because those are the numbers in our denominator. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So our common denominator that they have in common, the smallest one, is 6. Okay? So therefore, we're going to multiply both sides of my equation by 6. All right? So that gives me 6 times 2x plus 6 times 4 minus 6 times 3 halves x equals 6 times 1/3 times the quantity x plus 5. So now next line we have 12x, we're simplifying, plus 24 minus 18 over 2x equals 6 over 3 times x plus 5. Now we want to simplify. We have 12x plus 24 minus 9x equals 2 times x plus 5. Combining like terms. Remember, our like terms are 12x and x, 12x and 9x, I'm sorry. So this is a subtraction sign in front, so that's a minus 9x. So I'm just going to rewrite it so you can see it. And on the other side, I'm going to distribute that 2. Okay, so 2 times x is 2x. 2 times 5 is 10. So combining like terms, I have 3x plus 24 equals 2x plus 10. So now I'm going to combine my like terms. I'm going to subtract 2x on both sides here. And now that all my variables are on one side, I'm going to now bring my constant on the other side by subtracting 24 on both sides. So now this is gone. And I'm left with 1x equal a negative 14. So therefore, x equals negative 14. Okay? So that's if I got rid of the fraction. So I'm going to solve it again where we do not get rid of the fraction and we leave the problem as is. Okay? So that gives me on the other side, I'm going to work that out. So you have 2x plus 4 minus 3 halves x equals, and I'm going to do the distributive property. It's tripping. Let me move it over. We have 1/3 x plus 1/3 times 5. Okay, so here to combine like terms. 2x, if my common denominator is 2, that's the same thing as saying 4 over 2. Because why? 4 over 2 equals 2. So 4 halves equals 2x, equals 2. Okay? So because I'm dealing with a fraction and I want to combine it with the like term with the other fraction, okay, I have to make it look as a fraction so they can have the same denominator. Okay? So 2x is equivalent to 4 halves x, and I'm just going to move this 3 halves closer to it because the next line I'm going to subtract them. Okay, so I have 1/3 x plus 5/3. When I multiply 1/3 times 5, I get 5/3. Okay, so now on this side, I'm left with 1/2 x when I subtract. Remember, you subtract the numerator and keep the denominators. Plus 4 equal. These are unlike terms, so I have to leave them the same. So now I want to combine my like terms. I'm going to combine by subtracting my fractions, 1/3 x minus 1/3 x. They have unlike denominators, so I have to make them a common denominator. Okay, so the common denominator will be 6, right? Because 2 and 3, 2 times 2 is 2. I'm sorry, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. We have 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So my common denominator is 6. So if I have 1/2 equivalent to 3/6 and 1/3 is equivalent to 2/6. Okay, so now I have 3/6x minus 2/6x plus 4 equals, remember this cancels, equals 5/3. Okay, so now I want to combine like terms. I have 1/3 x, I'm sorry, 1/6 x plus 4, and I want to subtract 4 on both sides. So 5/3 minus 4. This cancel and leaves it 1/6 equals 5/3 is the same as what number with 3 in the denominator would give us 4. If you said 12, you are correct because 12, we'll write in a different color at the bottom, 12/3 equals 4. Okay, you can do a common denominator by placing 4/1. But least common denominator was taught in a previous grade, so I'm hoping that you remember how to do that. If you need assistance, let me know. Okay, so I have 5/3 minus 12/3. Unlike signs, you remember you keep the same denominator, but I subtract just the numerators. And a negative 12 is larger than 5, so you subtract and take the sign of the greater absolute value. Okay, so negative 12, or 5 minus 12, you have a positive 5 minus 12. Go ahead and do the math when you subtract. You should have gotten negative 7/3. So negative 7/3 equals 1/6 x. Then we'll multiply both sides by the reciprocal, 6/1, to get rid of this fraction. And I want x by itself. So therefore x equals, if I look across, 3 goes into itself 1 time, 3 goes into 6 2 times. So I'm left with negative 7 times 2/1. Therefore, x equals negative 14. Now, I hope looking at this problem shows you why I don't like dealing with fractions. I'm great with fractions, but most kids do not like it. Even though you get the same answer. If you're really good at working fractions, feel free, be my guest, have a ball. But if you can get rid of fractions in the beginning, like we did with this problem here, okay, then you should be fine, okay? Get rid of the fractions first because it's easy to make a mistake when you're working out fractions with the whole problem, but either way it goes, you get the same answer. All right, number 7. Mr. Gordon buys packages of clay. Some of the packages are on sale. 5 packages that are on sale cost the same as 3 packages that are not. They gave you the equation and they told you that P is the price of a package of clay that is not on sale. What is the price of the package of clay that is not on sale? So they actually just want you to solve for P. All right, so hopefully you've already worked this problem out. If you didn't, pause the video, come back, and check your answer. Okay, I'm just going to work it out for you so you can check your work. You want to use the distributive property. 5 times P minus 5 times 2.50 equals 3P. They give us 5P minus 12.50 equals 3P. Because I already have a constant over here, I want to subtract 5P to both sides to bring it on the other side to connect with the other variable. This will cancel. I'm left with negative $12.50 equals negative 2P. Divide both sides by the coefficient negative 2. A negative divided by a negative is a positive, so that should give you $6.25. So if you pick C, you got the right answer. Number 8, let's check and show your work. We want to do the distributive property here. I'm going to show you a little trick because we're dealing with decimals. Decimals also can be tricky, but if you know your place value, okay, here's my decimal. This is the ones place. This is the tens place. This is the tenths place. This is the hundreds place. Because all of these numbers have one digit in the tenths place, if I multiply each of these by 10, I move the decimal one place to the right. So now this gives me the number 4, the number 25, and the number 125. Okay, so I'm going to multiply both sides of this equation by 10 so I can get rid of those decimals. Okay, so when you do that, that gives me 10 times 40 hundredths. And in parentheses, you have 20 minus 10m. Then I have to multiply 10 times each one of these terms. Each term have to be multiplied by the 10. All right, so now this gives me 4 times 20 minus 10m equals 25 minus 20m minus 125. Now I'm going to use the distributive property and distribute this 4 to the 20 and to the m. So now this gives me 80 minus 40m equals, I'm going to combine my like terms. This is a term that's alike with this one. So 25 minus 125 gives me a negative 100 minus 20m. All right, so I have my variables on one side. I need to bring them together. So I'm going to add 40m on both sides so I can combine my variables. And I'm going to want to get rid of this 100 so it can go on the other side and connect with that 80. So I want to do the inverse. It's a subtracted 100, so I'm going to add 100 to each side. And that cancels. And this cancels. So now I have all my variables on one side and my constants on the other. So this gives me 180 equals a positive and a negative. Subtract, take the sign of the larger absolute value. It's 20m. Divide both sides by 20. M equals 9. Okay, therefore, the solution is M equals 9. All right. So, guys, for practice, if you don't have any questions for practice, I want you to go ahead and solve these equations. I really want you to focus on the solutions to both of these equations. And then I'm going to come back Monday and show you how to work the problems. Please do them first so you can use this as a check because this will be on your quiz on Wednesday next week. All right, guys. So, excuse me, you should go ahead and complete numbers 1 through 4, and then we'll pick up on Monday on our next lesson. I appreciate your time. Y'all have a great day.